It is terrific that you're hanging on in there and making such great progress with this course as we enter the final few days of building really important expertise. The topic for today, for week 8, day 3, is about continuing to strengthen, to upskill, build in one more skill, but also re-summarize, revise some of the stuff that we've done in the past. So today we're going to look at something new, structured outputs, which is something actually that is quite a recent innovation, a way that you can tell frontier models that you want them to respond according to a particular specification. So we'll be doing that today. And we're also just going to be doing more work experience with frontier models, carrying out something which is going to be a throwback, a callback to the first week, because we're going to be doing some internet scrapage as we had done in the past, and using frontier models to help synthesize data. You remember we wrote a summarizer way back. The Reader's Digest of the internet was our week 1, day 1 instant gratification. Well, we're taking that a couple of notches further. So that's the plan for today, and a lot of this, again, is going to be about revising, building, and experimenting. So let me just say a few words about structured outputs. So structured outputs, you remember in the past we've used JSON generation. We've said that we want the model to respond with an output format in JSON, and then in the prompt we describe exactly what that JSON should look like. And it's not 100% reliable. It's actually very good. It's frequently, if not almost all the time, will respond with JSON. But where it starts to go wonky is if you've got really complicated objects that you need it to respond in. It will, after a while, potentially hallucinate in some parts or give back wrong formats. So the idea of structured outputs was to be more directive about specifying exactly how the model should respond. And the way you do that is you define the response with a class, with a Python class. And it's actually going to be a class which is going to be a subclass of something called BaseModel from Pydantic, which you may have already had experience with if you're from an engineering background, but don't worry if not, I will show you. You make a subclass of BaseModel and you use that to describe exactly what you're looking for. And then you specify that class when you call OpenAI, and it will create an instance of that class in what it sends back to you. And so that's the idea. It's useful, as I say, for generating data in precisely a structure that you need. It needs to be compared with an alternative approach, which is use of tools, function calling, that we looked at, again, some time ago. And they're quite similar techniques for ensuring that a particular type of structure comes back in the response from the model. And there's pros and cons of both of them. Generally speaking, the recommendation is that if you are going to be hooking up your model directly to application code, so that it's going to be making calls to functions which need to have a particular method signature, then it's better to use function calling and tools. That is the better model, because then it will absolutely respond according to that JSON structure that you've defined with the right parameters for calling your function. If what you're looking at is to try and generate data in a particular format for downstream consumption or something, then structured outputs is the way. So those are some of the pros and cons, and it's something that you get a feel for after you've tried it for a while and get to appreciate when one performs better than the other. But with that introduction, let's head over to Jupyter Lab. We're going to try it out for ourselves. And welcome once more to our favorite place to be, Jupyter Lab, the paradise for a data scientist experimenter. So, as we launch into the day 3 notebook in week 8, you'll see that there are precious few comments this time round. I'm commenting the code that is our production quality code in the notebooks. At this point, you guys are pros. You don't need a whole ton of waffle from me. So we just dive straight in. So I'm going to begin with some imports as we get into today's puzzle. I'm going to set up some environment things. And now we get to the first piece of substance. I sneakily imported something called scraped deal. here without mentioning it, but I now have this scraped deal, and I'm going to call fetch with setting show progress to true. And I'm going to run that without telling you what it does, because it takes a couple of minutes, so we might as well let it run, and then I will talk more about it. So kick it off. Off it goes. So what is scraped deal? It is sitting in the agents folder in the package, and it is in part of deals.py. So let me show you deals.py. So this is a Python module which starts by defining a series of feeds, and these are URLs to RSS feeds, which are useful ones that happen to have good deals being announced in various categories. And these categories happen to be close matches for the categories that we know a thing or two about because our model was trained for them: electronics, computers, automotive, and then mostly smart home and home garden. So here are some feeds. There are a bunch of others, and if you have the stomach to wait a bit longer, you can slap in a bunch more feeds in here and have a bigger data set to work with. So then there are some utilities here that you can look through in your own time. A method called extract, a function called extract, which cleans up some HTML and returns useful text. And then there's a class scraped deal, and this represents a deal that we have retrieved from an RSS feed. So it's not exactly scraping, it's retrieving it from RSS, but we will do a bit of a lookup as well. So there's some truth to it. What we do in the init, we take something called an entry, which is just a dictionary of values, and we're going to parse in, and this is something we get straight from the RSS feed. And what we do is we pick the title, the summary, and we take the links. And then if you look at here, what we do here is we take its URL and we actually go and fetch that. So we are doing some scraping here. Sorry. We do some fetching of that URL and we put the results in stuff, and then we parse stuff with beautiful soup. So this is similar to what we did in week 1, day 1, when we were parsing URLs that we retrieved from requests.get. Okay, and then there's some more stuff here that takes the contents and scrubs it, and then we potentially build some features if we have the features. So this is all a bit of scraping code to be able to take something that comes in on our RSS feed, clean it up, and turn it into a record. And then there's something that prints what it is. And this class method fetch is exactly the one that we just kicked off a moment ago that you can see has finished running. And what it does is it iterates through all of the feeds, and it calls something called feedparser.parse. And feedparser is a package that I've imported, which is a useful package that allows you to pull RSS feeds, and it will give them to you as a dictionary. So we are using feedparser as our Python package for doing this. And we're just taking the top 10 that comes back from each of these different feeds. We take the top 10 deals that we get from each one. And of course, this is something where you can choose to bring back more data if you wish. For the moment, I'm just constraining it to that number. And then for each of them, we create, this is ourselves, we create an instance of us for that entry. That entry, of course, is the dictionary that we looked at a moment ago. And there's a little time.sleep in here. If you're wondering about that, that's because I figured that since we're then going and doing a get to retrieve that web page from this deals website, it was antisocial if we hammer that website with tons of requests, one after another, with a split second between them. So it's considered good scraping practices to put in a sleep so that you're not overly beating up a web server and being too needy. So this is a way of us being better citizens when we retrieve these deals from the websites. And then it returns those deals. So that's what I just did, and those deals should be sitting, waiting for us in this notebook. But I will first just mention a couple of other things in this useful module. There are these 3 classes here that are going to be important in a minute, because this is how we define structured outputs when we ask GPT-4 to respond. We are defining here a class deal, a class deal selection, and then a class opportunity. And you can see that these are subclasses of BaseModel. BaseModel is comes from the Pydantic package, which does a number of different things. One of the things it does is it very easily allows you to switch between JSON versions of a class and its structure and the class itself, and it also is able to enforce that a class adheres to a schema. So there's a lot about it that probably many of you are very familiar with Pydantic, but all you need to do to use it is simply create a new class that is a subclass of BaseModel. So our first class that we define is just called a deal, and it is something which just has a product description, a price, and a URL. That's it. Description, price, URL. And then we have another thing called deal selection. And this is what we're going to ask GPT-4o to respond with. We're going to tell it we want a deal selection. So this is the important one. And it's very simple. It's just something that has a list of these deals in a single attribute called deals. That's all there is to it. So deal selection means I want a list of deal objects. So if you think of this in your mind in JSON speak, what this will look like in JSON terms is it's going to be like this deal selection is a single object which only has one attribute, deals, and that is a list, and it's a list of things which are each objects. So when that goes into JSON, it will look like this. It has a product description, and it has a price, which is a float, and it has a URL, which is some kind of a URL like so. And that makes a deal, and there is a whole bunch of them potentially in a list of deals, and that makes up a deal selection. So if you look at the JSON that I just typed there and compare it to these class definitions, I hope it becomes clear in your mind how they are analogous to each other. This is just the JSON representation of this structure here. And indeed, when we say to GPT-4o, we want the structured output to be in this format, what we're kind of doing is saying we want this to be the kind of JSON that you respond with. That's all that's going on. So that hopefully gives you a sense of how this works. And I'll delete that now. That's not necessary. The final thing to mention is that there's also a class called opportunity that we define here, which basically is something which has a deal, one of these guys, and also an estimate, which is something later we're going to use when we are estimating the value of these deals. And then the discount is simply going to be the difference between the deal's price and the estimate. It's at how much of a discount are we finding that this is being offered. So that is the setup. And with that, let's go back over here. So fix something there. So we've just run scrapedeal.fetch. We can now look at how many do we have. We have 50 deals sitting in deals. The reason we have 50 deals is because we had 5 feeds and we asked for 10 deals from each feed, and so that comes to 50, obviously. So that's hopefully what you're expecting to hear. If we look at deal number 44, it prints out nicely because you might have seen I had I used one of the Python magic functions to make sure that it was going to print nicely, the repr function. And so that is what deal number 44 is. And if we do the full describe, this is the full bit of information we have about it. It's a Lowe's daily deal, garage storage, blah, 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 blah. Choose in-store to dodge the shipping fee. So here's the thing. If you look at that, you'll notice a couple of things about it. One of them is that the price doesn't come separately in the RSS feed. We don't get the price point. We just get the description of it. And the other thing you'll see about it is that this one doesn't even have a price. It's telling you how much off it is. It's telling you some things about the free shipping and things like that, but it's not actually giving you a price associated with this product. And that's a bore. And so that means that we're not going to be able to always use these properly. And we're going to have to do some parsing to figure out what is the actual price that's being offered against each of these items. What you'll find if you look at these items is also some of them combine multiple things in one blurb. There's maybe different models of the Apple Watch that are all being offered 20% off. And so trying to digest that and pull out what we want is going to be challenging, very hard to code that in a way that will be robust. And that's why we need to use a frontier model. We are going to use GPT-4o to take each of our RSS feed scraped deals and turn that scraped deal into something which is a good, useful deal for us. We're actually going to send it all 50 and say, look, we want you to find the best 5 deals which are most clearly explained from this big set, pluck them out and summarize it back to us. And we want that in structured output. We're going to tell you what format we want, and we're going to ask you to respond with exactly that format. And so now it's been teed up. You understand what we're trying to accomplish, and we're going to do it in the next video. Okay, so here we are back in Jupyter Lab, ready for the next use of a frontier model. And see this now as somewhere where you're really building expertise. This should be very natural to you. As usual, we start by considering our system prompt and being thoughtful about how we will prompt the model. What we're going to say to the model is, look, you identify and summarize the 5 most detailed items from a list by selecting deals that have the most detailed, high-quality descriptions and the most clear price. Respond strictly in JSON, blah, blah, blah. Most important is you respond with 5 deals that have the most detailed product description. It's not important to mention the terms. And now I have laid out here the JSON structure. I should probably mention that this isn't required because we're going to be using structured outputs, but I like to do this to use it as another opportunity to give more direction on exactly what's expected in each one. So this is something which you can experiment with, but strictly speaking, we shouldn't need to specify JSON like that. So that's my system prompt. The user prompt says, respond with the most promising 5 deals from this list, selecting those, blah, 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 blah. I will let you read it through, but you know this kind of stuff well. The deals, and then it lists the deals and it calls deal.describe for each of those. Okay, that's simple. So now let me just print the beginning. The user prompt is quite long, so I'm just going to print the first 2,000 characters of the user prompt so you get a sense for it. Here it is. Let's have a look. So there's the user prompt, respond with blah, 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 blah. And then here are the deals. And this is the description that we've taken from the description function that we looked at before, the describe method. So essentially, the task that we're assigning to GPT-4o is to digest this list of deals, pluck out from this list, and there's going to be 50 of them, pick the 5 which have the clearest description and from which it can take the price, parse the price out of this in a way that is most clear. And that is, of course, a fuzzy kind of problem that requires some thought. It's the kind of thing that would be only a year or two ago would have been unthinkably hard. Like, how would you do that in a reliable way using just engineering code? And it's the kind of problem that's so perfect for frontier models, because that kind of nuanced understanding and being able to realize that up to something means a price, and but up to something off is not the same as a price. That kind of logic is really hard. But frontier models are remarkably effective at understanding the meaning behind these expressions and using that intelligently to give us an output. So just based on these prompts, we're able to now say, okay, let's get recommendations. And now we're going to see a different API than usual because we're using structured output. So my function get recommendations completion is OpenAI, and look, it's a bit different here. This is, at least as of this moment, is a beta offering from OpenAI, but I imagine it's going to be fully productionized very, very soon. So you say OpenAI.beta, or that's beta for Americans, OpenAI.beta.chat.completions.parse. That's the way that you call this. And you provide the model as usual, and this is supported by GPT-4o Mini and GPT-4o, the Frontier version 2. As always, the message is, I'm just going to not even say it. You know it. You don't need me to tell you, surely. This is the difference. You remember in the past, we've used this response format as a way of specifying that we require JSON to come back. Now, this time, we don't say JSON. What we do is we pass in the class, the deal selection class. That's the class we were just looking at here, the one that I did some scrappy JSON for. We pass in that class in as our response format. And then when we're getting the result, we don't call our usual API calls. We say completion.choices0 as usual, .message, and then not content, but instead .parsed. And that is going to take the response and parse it into an instance of deal selection. And that is what it will return. So with that build up, it better return it. Let's run that code and see what happens and what we get back. So we are calling GPT-4o and GPT-4o Mini. We are specifying a particular structured format of output. It has returned. Let's see, why don't we print what type of thing has come back? Type results. Let's see what kind of object has come back. It is an agents.deals.deal selection. That is indeed the kind of object that we were hoping to get back. I think we better see what it actually looks like. It's going to be a set. It's a deal selection, which has within it deals is the one field. If you remember, deals was the one thing we set, and here are the deals. So let's find out how many deals we got back. We are hoping, of course, that we got back 5 deals. Let's see. We did indeed get back 5 deals, and let's print the first of those deals, and we get a Samsung Galaxy Watch Ultra, a top-tier smartwatch, and we've got a nice summary of this. And you'll notice this is actually looking great for us. It's looking like this is the kind of summary that we're going to want to use when we pass it into our prices to estimate the price of this. And GPT-4o Mini has pulled out a price and a URL. And of course, if we click on that URL, it's going to open up that deal. There it is. Wonderful. So it is working well for us. Okay, now the last thing to show here is that we are going to look to import our scanner agent. So I'm going to do the thing again where I'm going to kick this off because it's going to take a minute or two. And while it's running, I'm going to go over and show you what the scanner agent is. So the scanner agent is over here. This is a bunch of code that's going to look very similar to the code that we looked at before. And so it's just been written now with comments and with better structure so that this is something we can consider to be production quality. But it has the system prompt that we just looked at. It has a user prompt that we looked at. And it says respond strictly with 5 deals, no more. And what we get is an init method that sets it up and connects to OpenAI. The fetch deals is the method that we were just looking at that does gets a list of scraped deal by calling scrapedeal.fetch, just as you would expect. What it also does here, though, is that potentially it gets a memory object, which is a list of URLs, and it will remove from the results anything that it remembers has already been surfaced in a previous search. And this is how we make sure that we fetch new deals, not deals that we've already looked at before. And of course, memory, which is one of the facets of building an agent framework, is something we'll be looking at more in the future. And then we make user prompt, and then we do, this is the same code as before, and then scan is basically exactly the function that we just looked at. We make a user prompt, and then we call openai.beta.chat.completions.parse. We pass in the model. We specify that the response format needs to be the deal selection class so that we know that it's going to return that. And we parse it back into result. And that is what we get to right here when we then we do first remove any deals if the price isn't greater than 0. We don't want to return deals which have 0 price, and we return that result. And if we got no deals back, because perhaps we'd already surfaced everything, then we return none. And that's indicated by that optional at the top there. So that's the class. And with that, let me go back to day 3, and we should see that the results have come back. Now, one of the things I'm aware of that you may have caught, you may have noticed this yourself when I was doing this, but I was busy thinking about this while I was talking, is that I think we might have just seen a goof from the model, that the price here it's saying is $350 associated with this Samsung Galaxy Watch. But I think when this website came up, let's close this down, that it says up to $350 off with trade-in. If you have another device, you can save up to $350. So after I showed off about how Frontier models are so incredibly good at this stuff, this is an example of a mistake that the model has actually made, that it thinks that this is worth $350 when in fact it's $350 off. So I should eat my words, and it did actually get that wrong. And it's going to be interesting. It's useful to have learned that and to have seen that. And I might try adding that in to the system prompt and see if we can improve on the performance of that now that we see that it can make those mistakes. Anyway, I will see you next time for the slides. Okay, so I fibbed. We're not going back to the slides. We're going to stay in Jupyter Lab for one more minute because I can't let go of that problem that embarrassingly we discovered whilst I was talking last time. I don't know if you noticed, during the lecture, I was on my mind. I was like thinking, did I just see it do that? And how do I fix that? So yeah, obviously that was poor, that the model was fooled by something that said the price was off. And so yes, we should go back and fix that by being more directive in the prompt. So what I've done is I've come back in and I've just explicitly put in both the system prompt and the user prompt, be careful with products that are described as XXX off or reduced by XXX. This isn't the actual price of the product. Only respond when you are highly confident about the price. I put that in both prompts, and then I've got here the new prompt with that in it, and then I've called get recommendations again, and I've looked at the deals, and at least anyway, this first one is showing price is $6.99, and we open up this deal, and you can see that the price is $6.99. It's got that right. I suppose, look at the next one as well. Let's see what this is. Price is $560. Let's see what we get. Price is $560. So I think we fixed that problem. Obviously, much more analysis is needed, and we should go through all of them, which I will put some work into that. But I think it's turned out to be a positive. It's very helpful because it shows you the kinds of stumbling blocks you can get into, how important it is that you do double, triple check the responses coming back from the models, and then tweak the system prompt and user prompt as you learn more about the interpretation and some of the negatives, some of the vulnerabilities. So it was instructive. I think it's useful in building up your knowledge to see how one goes about treating those problems and looking for them. And it shows that I was wrong to be so confident that GPT-4 Mini was going to understand that. And in fact, we needed to do more homework to prove that. We would probably find that GPT-4o, the main model, wouldn't suffer such problems and wouldn't require such directive prompting. But certainly we can tell that GPT-4o Mini does. Anyway, I hope this has turned out to be positive, a useful little extra. And now I will go, of course, and add that to the main agent class so that we have productionized that change, and we will push on with the slides. It's remarkable, but you are now at the 95% point. There's 5% remaining of this course. Maybe it's not remarkable because hopefully you're feeling like you've built up such strong skills and you're getting really experienced. You probably saw some of the problems I was having a moment ago before I did and knew exactly how to sort them out. So what you can now do is this long list of things. I could no longer fit it into 3 bullets and I struggled to fit it into 4. There's far too much stuff. I had to put structured outputs in here in the first bullet just to try and fit it in. But there's so much that you can do across closed source and open source models, calling them in all sorts of ways, now including productionizing them. And now we change topic to talk about agent workflows, agentic frameworks. This is something that we touched on in previous weeks. We used function calling, which we said at the time is a kind of light version of agent workflows, where you do have a task that's being divided into smaller tasks with specific models carrying out tasks. And as you take that up a notch and start to get to an environment like we've been talking about this week, where you have multiple models that are all working independently, potentially being organized by a planning task, a planning agent, and then put together in some sort of a framework which has memory and which can live beyond, outside the context of a human necessarily interacting with it, you're getting to a full-on agentic workflow. And that is what we will be talking about next time. And I'm really excited about it. And I will see you then.